Hello, my name is Sierra Cassell, and the purpose of today's video is to learn how to use long division to divide polynomials. Today, we are solving a question that uses the application of dividing polynomials. The question can be found on page 170, question 11, in the Nelson Advanced Functions Grade 12 textbook. The question asks, if the volume of the box is x cubed plus 6 squared plus 11x plus 6 centimeters, and the box is x plus 3 centimeters long and is x plus 2 centimeters wide, how high is the box? Given the polynomial equation, in order to solve for the height, you must divide the volume by the product of the length and width. This will require you to go all the way back to Unit 2. Do you remember anything from Unit 2? No? Don't worry. We're going to go step by step on how to solve this question. So, back to the question. If the volume of a box is x cubed plus 6x squared plus 11x plus 6 centimeters, and the length of the box is x plus 3 and the width is x plus 2, how high is the box? First, let's start with the key components that comprise this question. The volume formula, length times width times height equals volume. 2, isolating the unknown variables. And 3, dividing polynomials, my personal favorite. So now that we know the key components that comprise this question, let's start with the first step. Step number 1 is identify the known and unknown variables. The variables we know are length, x plus 3, width, x plus 2, and volume, x cubed plus 6x squared plus 11x plus 6. Now, plug in our known variables into the volume equation. The first step are too easy, so buckle up. Step number 2 is to use FOIL to create one polynomial instead of two. The product of x plus 2 and x plus 3 is x squared plus 5x plus 6.
Then divide x cubed plus 6x squared plus 11x plus 6 by x squared plus 5x plus 6 to completely isolate for the height. Dividing polynomials is the exact same as long division, so don't be frightened. Similar to long division, we have a divisor, dividend, and quotient. A handy tip when long dividing is to follow this order. Divide, multiply, subtract, and bring down. A handy acronym to remember is dad, mother, sister, brother. Now let's break this into steps. Step 1. For a moment ignore the rest of the terms and just use the variable with the largest exponent, in this case, x squared. Using x squared, divide the first variable. Where do I put the answer? Good question. The exponents of the quotient and the dividend must line up. Step 2. Multiply each term in the divisor by the quotient and put it underneath the dividend. Underneath the dividend will be x times x squared, which is x cubed, x times 5x, which is 5x squared, and x times 6, which is 6x squared. Step 3. Subtract the two polynomials. By doing so, the initial first term will be cancelled out and will equal 0. The difference should be 0 plus x squared plus 5. The last and final step to dividing polynomials is to bring down the last term and repeat. Apply the same steps you did to the polynomial above. Repeating the same steps, we would first divide x squared by x squared, which equals to 1. Multiply 1, the quotient, by the divisor, x squared plus 5x plus 6, which will therefore cancel out and leave no remainders, having the final answer be x plus 1. A career and job that encounters problems like this would be architects, specifically solution architects. Solution architects solves all problems relating to the dimensions and logistics of structures like height, width, length, and volume. Thank you for tuning in, and hopefully this video was the stairway to the solution.